Yesterday we were discussing about applications of electrochemical series. Silence. How many applications completed? What was the last one? Possible to identify? How to identify spontaneity of the reaction, whether the reaction is going to be feasible or not. Spontaneity of the reaction can be calculated by continue the same one by using delta C naught is equal to minus NF into E naught of the cell. This is one formula. With the help of this one, it is possible to know whether the reaction is spontaneous or non-spontaneous. Delta Z naught is equal to minus NF into E naught of the cell. Delta Z naught indicates standard free energy change. Standard free energy change. About this one, we will be studying in thermodynamics. Next one, N is the number of electrons involved in the reaction. Number of electrons involved in the reaction, either oxidation or reduction, it will be always equal. F is nothing but Faraday's constant. Faraday's constant. And E naught of this cell is nothing but it is EMF of the cell. EMF of the cell. If the value of delta Z naught is equal to any negative value, delta Z naught is equal to any negative value, then we can say that reaction is spontaneous. Reaction is spontaneous means feasible. Reaction takes place. And if any value of positive delta Z naught makes the reaction non-spontaneous. Reaction is non-spontaneous. Reaction does not take place. And if the value of delta Z naught is equal to 0, we can say that reaction is at equilibrium. Reaction is at equilibrium. Delta is not equal to 0. Reaction is at equilibrium. If you are having any type of doubts, clarify. No, don't worry. What is delta Z naught? Standard free energy change. N is the number of electrons involved in the reaction. F is Faraday's constant. E naught cell is nothing but EMF of the cell. This EMF of the cell is going to be calculated as E naught of the cell is equal to, this is E naught of the cathode minus E naught of the anode. Cathode minus anode of the respective E naught. If delta Z naught equal to negative, reaction is always spontaneous. Delta Z naught equal to positive, reaction is non-spontaneous. When delta Z naught is equal to 0, the reaction is going to be at equilibrium condition. Now, how to identify whether the reaction is going to be feasible or spontaneous? Any negative value of delta Z naught makes the reaction what? Spontaneous. Any negative value. No need to go with corresponding to all the different types of values. Any negative value makes the corresponding substance spontaneous. Suppose if I write one reaction, if I write one particular reaction, this is going to be CuSO4 plus. This one is reacted with Zn. This one gives rise to ZnSO4 plus. It is what? C. It is going to be C. Now we have to identify whether this reaction takes place or not, feasible or not. Here copper and Zn electrodes are going to be there. This is copper sulfate zinc replacing copper from the copper sulfate to form zinc sulfate and corresponding copper. In this reaction, which one is going to be oxidized and which one is going to be reduced here? This is 0. Here it is plus 2. 0 to plus 2 is going to be oxidation. Next, this is plus 2. It is 0. Plus 2 to 0 is reduction. Plus 2 to 0 is going to be reduction. Okay. Now in this corresponding reaction, the formula is going to be delta Z naught is equal to minus NF into E naught of this cell. We have to calculate separate E naught of this cell. E naught of this cell is equal to what formula? E naught of cathode minus E naught of what? Anode. Now, copper and Zn both are going to be present here. This is copper and this is going to be Zn. When copper and Zn both are going to be connected according to Daniell cell, yesterday we have discussed about Daniell cell. Between copper and Zn, which one undergoes oxidation? Zn undergoes oxidation. Zn undergoes oxidation means this is present at the anode terminal. This is present at the cathode terminal. Yesterday we have discussed. What is the reduction potential of copper? Plus 0.34. See the yesterday's list. Zn is having minus 0.76. Correct? It's there or not? Which one is going to be at the cathode terminal here? Cathode terminal is going to be copper. It is 0.34 minus of minus 0.76 volt. Are you getting this one? This value is going to be equal to how much it is? It is 1.1 volt. This value of E naught of this cell is equal to 1.1 volt. How it is 1.1? Once again I'll explain. When copper and zinc electrode both are going to be connected here, copper undergoes the process of reduction and zinc undergoes oxidation. Oxidation always takes place at the anode terminal. Reduction takes place at the cathode terminal. Cathode minus anode is going to be there. Cathode value is going to be 0.34. Anode value is going to be minus 0.76. After adding these two, the E naught of this cell is equal to how much? 1.1 plus 1.1 or minus 1.1 plus 1.1. Now it is delta Z naught is equal to, just to observe, minus. What's the value of N in this reaction? How many electrons are lost and how many electrons are gained? 2. Number of electrons lost is always equal to number of electrons compulsorily. This is going to be 2 into Faraday's constant. This Faraday's constant value is 96,500 coulombs. 1 Farad is equal to 96,500 coulombs. It is 96,500 coulombs into what's the value of unit of this cell? It is 1.1 volt. We don't require the corresponding value, just it is going to be negative value is obtained. Yes or no? When negative value is going to be obtained, what we can say? The reaction is going to be spontaneous. Here this one point is going to be very clear. If the value of E naught of this cell is going to be positive, E naught of this cell is going to be positive, delta Z naught will be negative. If E naught of this cell is going to be negative, this negative and negative becomes what? Positive. When delta Z naught is going to be positive, reaction is not spontaneous, does not take place. Clear? Okay. So in this way, it is possible to identify whether the reaction is going to be feasible or non-feasible. Takes place or does not take place. Read out. Check whether this reaction is feasible or not. What is second reaction? Aluminium sulfate reacts with silver to form silver sulfate plus aluminium. Don't discuss. In case, some case, if you apply your common sense, also you can get the answer without writing anything. Not takes place. See the electrochemical series. In electrochemical series, aluminium is above and silver is below. Aluminium is above and silver is what? Below. Higher element can displace the lower element, but lower element never displaces. It's not possible. So this reaction is how to prove it? By using formula. Delta Z naught is equal to minus NF into E naught of this cell. Once again. What's the value of E naught of this cell? E naught of this cell is equal to, this is E naught of cathode minus E naught of what? Anode. Cathode means which one will be there at cathode? Aluminium will be there or silver will be there? Huh? This is aluminium, this is going to be silver. Between these two, which one undergoes oxidation easily? Aluminium. Oxidation means it is going to be present at anode. This is going to be present at cathode. Value of silver is going to be plus 0.80. Check once. Aluminium is going to be minus 1.6. Cathode minus anode means this is 0.80 minus of minus 1.66. 1.66. 1 second. Cathode, which one? What?
This reaction, aluminum is at cathode and
this is going to be 1 second. Az is going to be the 0 and Az is going to be what? Sorry, this reaction is not balanced. You take Az to SO4 thrice, Az to SO4 thrice, or Az to SO4 going to be 2, and 3 2s are 6, just 1 minute. This is going to be 6, and 2Al, this is going to be 2Al, 3 sulfate is going to be there. Just you observe here, Az to this one Az plus. Here it undergoes the process of what? Oxidation. And here Al is going to be having plus 3 gets converted into 0. Aluminium undergoes what process here? Reduction. When usually silver undergoes the process of reduction and aluminium undergoes oxidation usually. But according to this reaction, if you proceed, Az is going to be undergoing oxidation means this one should be present at anode. This one should be present at cathode. Now this value becomes what? This value is going to be, cathode is going to be how much? It is minus 1.66 minus it is going to be plus 0.80 volt. What is the value of this one? Negative or positive? Negative. What is the total value? What's the total value? Minus 1.66 minus of plus 0.80. Minus 0.86. Minus 0.86. 0.86. Correct? Pass. 2.4 plus minus. This is going to be minus 2.46. Okay. Now this is equal to minus 2.46 into what's the value of number of electron? This is 3 into E naught of this cell is going to be getting like this. What's the value of here? Minus 3 into 96,500 into it is going to be minus 2.46. Totally this minus and this minus, the value is going to be what? Positive. Delta Z naught equal to positive means this reaction not feasible, does not take place. Why it does not take place means actually when silver and aluminium are going to be combined together, silver has to undergo reduction and aluminium has to undergo. But here it is going reverse. Because of that reason, it is not feasible. This reaction is not feasible. In this way, it is possible to identify which reaction takes place and which reaction does not take place. Clear? Read out. Any negative value of E naught of this cell makes the reaction non-spontaneous, and positive value of E naught of this cell makes the reaction spontaneous. Any reaction is going to be spontaneous means delta Z naught must be equal to negative. Lower the value of delta Z naught, greater is the spontaneity. As the value of delta Z naught goes on increases, reaction becomes more and more non-spontaneous, and delta Z naught equal to 0 means reaction is going to be at equilibrium. Last one you read. Number 5 or 6? Point. Yesterday's 4, 5. Last 5. 5. No. It's not equal to gain of electron. Anyway, we can calculate, but totally our intention is to get positive value. Okay, we'll consider that one also. What's the number of electrons lost by silver? One silver loses how many electron? 1. Here oxidation state of silver is +1. One silver loses 1 electron. One aluminium Al plus and gains how many electron? 3 electrons. The number of electrons lost must be equal to number of electrons gained. If you take one silver loses 1 electron, means 6 moles of silver loses 6 moles of electron. Loss of electron equal to 6. Aluminium is going to be how many aluminium are there? 2 aluminium. 1 aluminium ion gains 3 electrons. 2 aluminium ion gains 6 electrons. In that case, here you are right. This one is going to be equal to 6. Correct. But I'm not worrying about that value. I'm worrying about only corresponding whether it is negative or so that is the required thing. But at the time of calculation, you have to use that value as 6, not as 3. Read out further. Last point you write. Any higher element can displace. Any higher element can displace lower element from its salt solution. But lower element cannot displace higher element. Lower element cannot displace higher element. The reason is going to be it is because of oxidation and reduction. Here some examples just I mentioned here. It was lithium, next it was magnesium, after that aluminium, this is Fe, this is copper and this is Az. Just observe. Some examples I mentioned here. Lithium the last one it is going to be still many elements are going to be there. Now for our discussion only 8 to 6 examples. Lithium to next one it is going to be Az. Suppose we are going to be having MgSO4. From this magnesium sulfate, magnesium has to be displaced. That is possible by which of the 6 elements? Leaving this magnesium, because magnesium is a part. Which element can displace magnesium from magnesium sulfate? Only lithium. Remaining element cannot displace that magnesium because this one has to undergo the process of oxidation and magnesium has to undergo reduction. If I consider this is MgSO4 plus this is going to be Fe. This is going to be converted into what? FeSO4 and this is what? Mg. Just to observe here, when magnesium and this is going to be iron, both are going to be considered here. Fe is going to be undergoing oxidation here, 0 to +2, this is oxidation. Magnesium +2 to 0, this is going to be considered to be what? Reduction. When magnesium and Fe are going to be present in the reaction, magnesium has to undergo the process of here magnesium is undergoing, hence this is not does not take place. But reverse takes place. Reverse हो रहा है. FeSO4 plus magnesium gives rise to what? MgSO4 and Fe. That is going to be possible. And if I consider some of the element is going to be Az2SO4 is there. That is silver sulfate. This particular silver from the silver sulfate can be displaced by which of the following elements can displace? Higher element can displace, but lower one cannot displace. But higher and lower don't get confused here. Higher element means which is going to be having negative reduction potential, and lower element means which is having positive reduction potential. Because in some of the textbooks they have taken this one is reverse. I have mentioned clearly in definition. What is the definition of electrochemical series or reactivity series? It's the arrangement of elements or electrode system in increasing or decreasing. Sometimes they may go with the negative to positive, or sometimes they may go with the positive to what? Negative. Again, higher and lower confusion higher means the element which is having negative reduction potential. Lower means which is having positive. So negative reduction potential element can displace element with positive reduction potential, but element with positive reduction potential cannot displace negative reduction potential. These are some important applications of what? Electrochemical. So with this discussion, the topic redox reaction is completed. To discuss. After this redox reaction, next topic, very important topic, that is what is this one? Equilibrium. Shall I use some time for discussion, for talking? 1 minute, 30 seconds, you can give that one. You can talk to any extent in that given time, but afterwards you should not talk. Atara beke time, matadli konta only wish. Only for talking. Non-stop matadbekavu. To discuss. Equilibrium. One of the most important topic in both class 11th and 12th. For all format of exam. Whether it is a board exam or it is a competitive examination, for all type of examination, this topic is going to be most important. How many questions will be there in NEET exam from chemistry? 45. Totally, how many topics are there in both class 11th and 12th? 30. 14 and 16, it is going to be 30 topics are going to be there. 30 topics. Now, some of the topics have been deleted. Without that particular deletion, totally 30 topics are there. 30 topics and total number of questions is going to be how many? 45. Means hardly from one particular topic, maximum 1 or maximum 2 questions are possible. But sometimes they ask about 4 questions from this topic. 4 fours are 16 marks makes the maximum difference in the ranking of a particular student. 16 marks. It's not the question of 16 marks. Just 4 marks makes a maximum difference. Lot of difference. Just 4 marks. So 16 marks means it is a huge difference in case of rankings or the particular seat allotted in a particular college. The maximum difference will be there. So that is going to be very important topic, that is going to be equilibrium. In first year, some topics are going to be playing very important role. First one is going to be chemical bonding. Very important topic. Chemical bonding. Next topic is going to be this equilibrium. Next one is going to be GOC, General Organic Chemistry. After that, next topic is going to be periodic properties. Compulsory question. Even the topic is going to be very small. Compulsory question from the periodic topics. Periodic properties. Next one, structure of atom. Structure of atom. Out of 45 questions, roughly around 22 or 23 questions will be from class 11. 22, 23 questions will be from class 11. In that 22 questions, minimum 50% of questions will be from these 5 topics. Hope you are following me. Minimum 50% of questions will be from these 5 topics only. Chemical bonding, equilibrium, GOC. The next one is going to be periodic properties, and after that, structure of atom. Maximum number of questions. Chemical bonding, minimum 2 questions. Equilibrium, if not 4, at least 3 questions will be there. 3 bit 2 on to 100%. There is no any compromise in that one. GOC, minimum 2 questions. Minimum 2 questions. And periodic properties, 100% 1 question will be there. One very simple question. Very simple question. You should not lose marks in case of such type of question. Structure of atom, 2 questions minimum. So roughly it is only 10-11 questions will be there. So from these corresponding 5 topics only. You have to concentrate to the maximum extent in these particular topics. And one of the important topic is going to be what? Equilibrium. Naturally, it takes more time to discuss the concepts present in this equilibrium. And equilibrium topic is having 2 parts. One is chemical equilibrium, and next one is Ionic equilibrium. Chemical and ionic equilibrium. We have to go with several concepts in this topic, equilibrium. In this first chemical equilibrium, first we have to discuss what is the meaning of equilibrium and how this equilibrium takes place in different physical processes. Equilibrium is going to exist in case of solid and liquid. Equilibrium is possible in liquid and gas. Equilibrium is possible between solid and gas also. And equilibrium is also possible in case of the different types of solution, gas and corresponding solution. We have to discuss about all those with examples. After that, how this concept of equilibrium is going to be takes place in chemical system, chemical reactions. So based upon this equilibrium, reactions are classified into two types. One is reversible reaction, irreversible reaction. What is reversible? The reaction which proceeds in both the direction, forward to backward and backward to forward. But what is irreversible? Which proceeds, which takes place in only one direction. That is commonly called as irreversible reaction. Homogeneous reversible and homogeneous equilibrium and heterogeneous equilibrium is that we have to discuss. After that, what is the characteristics of equilibrium and what is the meaning of equilibrium constant? We will come across with a constant called as equilibrium constant. Important properties are going to be there. And two different types of equilibrium constant we have to consider. One is Kc, next one is Kp. Equilibrium constant in terms of molar concentration and equilibrium constant in terms of partial pressure. Okay. Afterwards, we have to discuss about one important principle that is called as the Le-Chatelier's principle. What is the meaning of Le-Chatelier's principle and what are the important applications of Le-Chatelier's principle? You are not only studying the concept of Le-Chatelier's principle in equilibrium, in almost all topics, wherever equilibrium is going to be there Le-Chatelier's principle is applicable compulsorily. These are the contents of only chemical equilibrium. Next, moving on to next one part, that is ionic equilibrium. We have to discuss how the equilibrium exists in case of ions. Ions means charged species, positive and negatively charged species. There we have to discuss about the concept of acid and base. What is an acid and what is an base? According to three different types of theories. Arrhenius theory of acid and base, Bronsted theory of acid and base, Lewis theory of acid and base. What is this one? HCl is an acid or base? Acid. HCl is an acid. Very good. NaOH. This one is an base. What about BF3? So that we have to discuss. Whether BF3 is going to be considered as an acid or base. Actually, BF3 is going to be an acid. Boron trifluoride is going to be considered as a Lewis acid. What is the meaning of Lewis acid? What is the meaning of Lewis base? What is Bronsted acid? What is Bronsted base? What is Arrhenius acid and Arrhenius base? After that, what are amphoteric substances? Amphoteric. After the amphoteric substance, we have to discuss about conjugate acid-base pair. Conjugate acid-base pair. And next one important concept about the ionic equilibrium, that is the pH and pH. What about pH? pH. What's the pH of water? Pure water. 7. If pH is equal to 1, basic or acidic? Acidic. Strong acid or highly weak acid? Strong acid. pH equal to 6.99. Very, very weak acid. pH equal to 14. It is going to be strong base. And depending upon that pH, we are going to be having this pOH also. Usually pH is going to be determined for acids and pOH is going to be applicable for bases, but we can use both pH as well as pOH for both acids and bases. After that, we have to discuss about the buffer solutions. What is buffer solution? What are the applications of buffer solution? Different types of salt hydrolysis we have to discuss. So many type of salt we come across. Salt means probably you have heard about only sodium chloride is going to be considered as a salt. Like K2SO4 is going to be another one type of salt. KBr is going to be another one type of salt. Any particular compound containing positively charged ions and negatively charged ions. Usually metal ions and non-metal ions, wherever they are present, generally they are commonly called as salt. Various types of salts we have. Simple salt is there, double salt is there, complex salt is there, mixed salt is there, anionic salt is there, cationic salt is there, salt of strong acid and strong base, salt of strong acid and weak base, salt of weak acid and weak base. So many type of salts are going to be there. We have to discuss about all those type of salts. And after that, last one, solubility product concept is there. We have to discuss about that solubility product concept. So those are the contents of what ionic equilibrium. Now we cannot understand, we cannot remember all those points. Slowly, day by day, we will complete about all those different types of parameters. Basically, what is the meaning of this equilibrium? Equilibrium is going to be a very common process which takes place in all the different types of chemical and physical processes. Equilibrium refers to a particular state of a reaction where observable properties of that particular reaction remains constant. Observable properties means either temperature is going to be there, or color of the corresponding compound is going to be there, or some other particular properties. Wherever it remains constant, that particular state of the reaction is commonly called as what? Equilibrium. Generally, it is going to be considered as, actually that is not the definition, it is a simple way to understand what is the meaning of equilibrium. A state in a reaction where observable properties of the reaction remains almost constant, it is commonly called as what? Equilibrium. So here just right here, the state of a reaction, state of a reaction, state of a reaction where observable properties like temperature, pressure, color, etc. remain constant. Wherever these different types of properties remains constant in the reaction, that is commonly called as what? Equilibrium system. It's a state of the reaction where different types of properties are going to be remains constant, and that particular position is generally referred to be as what? Equilibrium. Generally, if I say consider one particular reaction here, equilibrium refers to a reaction which can proceed in both forward as well as backward direction. In brief, I can mention here, one reaction is there where A and B are the reactants. A and B are the reactants. A and B are going to be reacted together. When A and B are reacted together, what it forms? It forms a product that is going to be C as well as a D. What are C and D here? Products. What are A and B? Reactants. So A and B are going to be reacted together to produce corresponding product called as C as well as D. After a certain amount of time, reaction takes place between C and D also. When C and D again reacted together to produce the same type of reactant, that is going to be A and B, is called as reversible reaction. It is commonly called as reversible reaction. In the beginning of the reaction, just to try to understand, in beginning of the reaction, concentration of A and B was maximum. In the vessel, we have taken only A as well as B molecule. There was no any amount of C as well as D. Slowly, as the reaction takes place between A and B, the formation of C and D goes on, increases. Concentration of AB goes on, decreases, and concentration of CD goes on, increases. After a certain amount of time, when the reaction takes place between C as well as D, so C and D reacted together to form what? A as well as B. So concentration of CD goes on, decreases, and concentration of AB goes on, increases. How about this? What is this one? Seesaw. Yes, when you are going to be playing in a particular seesaw, you can go up and down like that. After a certain amount of time, when the concentration of AB is almost equal to concentration of CD, means at what speed the forward direction is going to be taking place, at the same speed if the backward direction takes place, the concentration of AB, A concentration is equal to the concentration of B is equal to concentration of C, which is equal to concentration of D. Whenever the concentration of A, B, C, D are going to be equal, that particular state of a reaction is commonly called as equilibrium. When you are going to be playing in a particular seesaw, after you can go up and down. Afterwards, you will come and compromise that. You will be entering into and compromise that the particular seesaw is going to be staying in a particular linear line. As a result, the particular weight of this side and weight of this side remains almost the same, and that particular position is commonly called as what? Equilibrium. That is a simple chemical reaction where equilibrium is going to be achieved between AB as well as corresponding what? CD. Whenever there is an equilibrium between the corresponding reactants and product, remember concentration of reactants is almost equal to what? Concentration of the product. Here I am using the word concentration. What's the meaning of concentration? It's a method of expressing the strength of the solution. Concentration of solution can be expressed in terms of normality, molarity, mole fraction, molality, ppm, so many different types of terms already have studied in case of some basic concepts in chemistry, right? Studied or not? Normality, molarity, Proceed. Okay. So I cannot explain that particular complete normality, molarity, and just strength remain means if I go with one particular word, one I'll explain about this. Normality means what? Normality is nothing but it is a measure of concentration of the solution. One method. Normality of the solution can be calculated by using one simple formula. It is mass of the solid, that is W2 into this is going to be 1000 divided by this is going to be equivalent mass of the substance into total volume of the solvent. With the help of this one, it is possible to calculate the normality of the solution. Generally, in our reaction, the particular substances may be 0.1 normal, it may be 0.5 normal, it may be 1 normal. Different concentrations are generally considered. Another one term that is going to be very, very similar to normality is nothing but molarity. What is the meaning of, what is the difference between normality and molarity? W2 is going to be the mass of the solid. This is going to be what 1000 is going to be there, divided by this is going to be molecular mass. In equivalent mass, we take what quantity? In normality, we take equivalent mass. In molarity, we take into this is going to be respective volume of the respective solvent. This is commonly called as what? Molarity of the respective substance. Don't write. That's not required. So totally, if you take either any particular solution is going to be having 0.1 normal or 1 normal, molarity is going to be there 1 molar or 0.1 molar, any different concentration will be there. If that concentration of reactant becomes equal to concentration of the product, in that case, the reaction is said to be in which position? Equilibrium position. Under what condition concentration remains same? Concentration of AB is equal to concentration of CD. When concentration of AB is equal to concentration of CD means it is very clear that at what speed of forward reaction is going to be proceeding. This is going to be forward reaction, this is going to be backward reaction. At what rate forward reaction is going to be taking place at the same speed? Backward reaction is also taking place. That is the equilibrium in case of different types of chemical processes. So, any particular state of a reaction where observable properties like temperature, pressure, color, etc. remains constant, that particular state is commonly known as equilibrium. Now we have to discuss this particular concept of equilibrium. Concept of this equilibrium in different type of physical processes. In physical processes. So what are the different types of physical processes where the presence of equilibrium is noticed? Equilibrium in case of different physical processes. First process, that is the equilibrium is going to be possible between solid and corresponding liquid state of the substance. It is commonly known as solid liquid equilibrium. How the equilibrium can be established between solid and liquid state of the substance? Solid and liquid state of the substance. Equilibrium is going to be possible here. Whenever, if you take a particular thermos flask, where temperature remains constant, it is an isolated system, a thermos flask. If you take a thermos flask, you are going to be placing certain amount of water molecules as well as certain amount of ice cubes. This is going to be one thermos flask is going to be there. It is one thermos flask. In this one, you have placed certain amount of water is going to be there. This is going to be water. Say for example, 100 ml of water is going to be there. 100 gram of water you can take and certain amount of what ice cubes are going to be. This is going to be different types of ice cubes. Total mass of ice cubes and total mass of water is going to be, it is same. There is 100 gram of ice cubes and 100 gram of water. You can take that water in terms of grams. Now both are going to be kept in this particular thermos flask where temperature is going to be maintained at 0 degrees Celsius. Temperature is going to be how much? 0 degrees Celsius. What happens this particular amount of ice and amount of water after certain amount of time? So 0 degrees Celsius is nothing but that is the temperature at which solid and liquid both are existing in equilibrium. Why both are going to be existing in equilibrium at this temperature? 0 degrees Celsius can be considered as a freezing point of water. What's the meaning of freezing point? Freezing point. What about freezing point? Boiling point, only better. Boiling point. What is the meaning of boiling point? Anyone? Boiling point. Somebody was saying that side. What is the meaning of boiling point? Huh? Boiling point. Anybody? Boiling point. Boiling point. What is the boiling point of water? What it means? At that temperature, liquid converts into gas. The temperature at which liquid gets converted into gas is commonly called as. It is not the correct definition. It is definition which is applicable up to class 10. But here definition is going to be different using another concept. That is not the actual definition of boiling point. Boiling point refers to the temperature.
The temperature at which both liquid and gas
Liquid and
gas coexist.
Liquid and gas coexist together. It is commonly called as boiling point. To some extent, it can be considered. Okay. So, boiling point of a substance or boiling point of a liquid can be defined as the temperature at which vapor pressure of the liquid becomes equal to atmospheric pressure. At what temperature vapor pressure of the liquid becomes equal to atmospheric pressure, that temperature is considered as boiling point. Now you cannot define boiling point without this particular vapor pressure concept. What is the meaning of vapor pressure? Suppose if you take certain amount of solvent in a container, this is a solvent is there, say for example water. This is going to be water, is going to be there. When water is going to be kept in the open vessel, if you are going to be observing this particular vessel containing water after half an hour or after 1 hour, whether same quantity of water will be present in the flask? No. Some amount of water gets evaporated. So on the surface of this one, some of the different types of gaseous molecules are going to be present. Because of this corresponding gaseous molecule present on the surface, some amount of pressure is going to be created on the surface of the liquid. That pressure which is created on the surface of the liquid because of evaporation of water molecule is commonly called as what? Vapor pressure. Vapor pressure is nothing but the pressure which is exerted on the surface of the liquid because of evaporation of more and more number of water molecules is commonly called as vapor pressure. So, boiling point is nothing but the temperature at which vapor pressure of the liquid becomes equal to what? Atmospheric pressure. You are heating certain amount of water. When certain amount of water is going to be heated in a container, you are going to be heating this particular water. This water begins to boil exactly at 100 degrees Celsius. When the temperature reaches to 100 degrees Celsius, water begins to boil. Why water begins to boil exactly at 100 degrees Celsius means at that temperature, vapor pressure of this liquid water becomes equal to what? Atmospheric pressure. Whether same water can boil at 100 degrees Celsius in higher altitudes? No, it is going to be boiling at different conditions of temperature because of the presence of different amount of atmospheric pressure. So, the boiling of the particular solvent, boiling of any particular solution purely depends upon external pressure or atmospheric pressure. So, here also at exactly 100 degrees Celsius, water begins to boil and that temperature is going to be considered as boiling point. Suppose to this particular water we add certain amount of sodium chloride. Anyone's solid you add. Anyone's amount of solid is going to be 5 gram of sodium chloride is added, 5 gram of KBr is going to be added, 5 gram of salt is going to be added. When salt is going to be added into corresponding this water, it forms what? Solution. What is solution? Mixture of both. This one is going to be called as solvent. This is going to be called as when solid and solvent both are mixed together, it forms what? Okay. After addition of the corresponding sodium chloride, 5 gram of sodium chloride and 10 gram of sodium chloride into this 100 ml of water. Now you tell me the boiling point of water is going to be equal to 100 degrees Celsius, or it is going to be less than 100 degrees Celsius, or it is more than 100 degrees Celsius. More than 100. Boiling point of a particular solvent, if you consider boiling point of solvent, is always less when compared to boiling point of a particular solution. Even if you add 1 gram of the sodium chloride into that particular water, boiling point of that particular solution is going to be greater than 100 degrees Celsius. It may be, even it may be 100.2 degrees Celsius, even then it is more than that particular 100 degrees Celsius. It all depends upon the amount of solute added into the respective solute. That is commonly called as boiling point of solution. Leave over that. Now, whenever solid and liquid are going to be present in equilibrium, here this 0 degrees Celsius is commonly called as freezing point of water. What is the meaning of freezing point? Freezing point of a substance can be defined as the temperature at which both the solid and corresponding liquid state of the same substance coexist together. The temperature at which solid and liquid state of the same substance coexist together, that temperature is commonly called as what? Freezing point. So when the temperature is going to be 0 degrees Celsius, we are not changing the temperature of this corresponding mixture. When both the water and corresponding this particular ice is going to be there, this particular H2O which is going to be present in case of liquid state, it is in equilibrium with corresponding H2O which is present in solid state. What is the process for the conversion of liquid into solid? What is the name of the process for the conversion? When liquid is not being converted into vapor, it is commonly called as evaporation. Evaporation. Again, these corresponding molecules are going to be collected in the same container. It is going to be called as condensation. Condensation. Now, what is the name applicable for this conversion? Liquid into corresponding solid. Freezing. This is going to be corresponding to freezing process. Freezing. What's the process for solid into corresponding liquid? This is commonly called as melting. Melting. Solid gets converted into what? Liquid. So that is commonly called as melting. The rate of melting is going to be always equal to rate of freezing. Because of that reason, liquid water and this particular solid H2O are going to be in what process? Equilibrium process. Initially, if you are going to be, the moment if you add certain amount of ice cubes into this particular water, if you add certain amount of ice cubes into water, probably number of water molecules may be more, or number of ice amount is going to be more, because conversion of one into another one takes place. But after certain amount of time, equilibrium never attains very quickly. Equilibrium takes some amount of time to proceed forward as well as backward. That is, here both the freezing of the corresponding liquid water takes place as well as melting of the solid ice also takes place. Because of the conversion of H2O liquid into H2O solid, again H2O solid into corresponding H2O liquid, whatever amount of ice cubes and whatever amount of water which was added earlier, that amount of ice cubes and water remains same, no change. When it is going to be remains the same, then only it is going to be said that in particular both H2O liquid and corresponding H2O solid are going to be at equilibrium. But when temperature is going to be different, when you increase the temperature or when you decrease the temperature, when you increase temperature, what happens? Which process takes place? Melting, backward reaction takes place. When you decrease the temperature, forward reaction takes place. But I have said that observable properties remains constant. Which one is going to be? Temperature is going to remains constant. Wherever such type of properties are going to be remains constant, then only it is possible to attain the position of what? Equilibrium. So one equilibrium is going to be attained here between that particular liquid and corresponding solid. After this one, next equilibrium is going to be possible between next state of the substance. Next state, that is second one. Second one, it is going to be liquid and gas equilibrium. Liquid and gas equilibrium. Is it possible to attain equilibrium between liquid and corresponding gas? Yes. You take certain amount of water in a beaker. This is going to be water present in a beaker. Here water is going to be taken here. This is going to be in closed container. If the container is going to be completely closed out, after heating this particular one, after heating this one, or without heating also, when temperature is going to be more, then more some amount of water molecules are going to be present as vapor. So now, in the beginning of the time, some amount of water molecules are going to be converted into corresponding vapor state. Vapor state. Actually, this one is going to be done by using one experiment by applying certain amount of an pressure meter. It is going to be called as manometer. With the help of manometer, we can identify how the amount of this water vapor and corresponding liquid are going to be in equilibrium. Now, if you consider this particular liquid water, this is going to be liquid water is going to be there. It is H2O. It is going to be liquid. This is also going to be H2O. It is going to be in state, gaseous state. If you are observing at equilibrium, the amount of liquid water and amount of this gaseous water are going to be same. How much amount of this particular water is going to be there? Same amount of this one is going to be there, because in case of this one, this is H2O. If you consider this is going to be liquid, H2O liquid gets converted into corresponding H2O gas. What's the name of this process? Evaporation. Evaporation. And the reverse process, H2O gas into corresponding H2O liquid, it is condensation. Here what we can say, under what condition both are going to be in equilibrium? When the rate of evaporation is equal to rate of condensation. In that case, liquid water and gaseous water are going to be in equilibrium. How much amount of liquid water gets converted into gaseous water? Same amount of gaseous water is also converted into what? Liquid water. Well, the process of evaporation is equal to condensation, then both are found to be in equal amount. That is commonly called as equilibrium present between liquid and gas. Next one, we will discuss about equilibrium present between, what is another one? Gas and solid. Gas and solid equilibrium, what type of substances we need to consider? Exactly, sublimation. Example for sublimation? Huh? Camphor. Next? Naphthalene. What is the formula for naphthalene? Common substance, C10H8. Naphthalene C10H8. C10H8. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hydrogens, how many are there? 8. C10H8 naphthalene. Common substance, camphor. Camphor? What about camphor? It undergoes the process of sublimation. Actually, what is sublimation? The temperature at which the solid state of the substance gets converted into gaseous state without liquid. That definition itself is wrong. We will discuss about what is the correct definition.